Okay, so for today's session, we are now looking at another concept in programming, which is recursion. Okay, so the objective here is for you to understand how recursion works and how do we break down a problem into two specific cases, the recursive case and the base case. Okay, so now let's put it in a story first. Okay, so let's say that uh, you found a suitcase, okay, while cleaning your room or cleaning your attic or your bodega, okay, wherever you stock your items, your bags, and you're looking for the key to open the suitcase, right? And now let's say your mother, your grandmother, or whoever is in charge of keeping the item says the key is actually found on this box. Okay. Now, when you open the box, you actually have the main box itself, which is the exact container. Okay, the main box. But inside those boxes, there are also boxes of items. Okay, and these boxes may have boxes inside them. Okay, so they are actually nested boxes inside. Okay, so how would you go about this? How would you search for the key?
Sir, I would fine. I would pull out a box first and then check all of the items inside of it first before proceeding to another box.
Okay, sige. In, uh, any other approaches? How would you actually search for items? Okay, for Jenny, she will actually uh, look at each box first until she finishes that box and then move to a different box. Tama ba?
Yes, sir.
Okay. So how about, sorry, Gerard, you're trying to say something?
No, yeah, I'd probably do the same also.
Okay, sige. Now let's put more scenarios here. What if we open one box, okay, and there are two boxes inside? Okay, how would we uh, go about it?
If there's two boxes inside one box, then I guess you check the two boxes inside that box also. And then if
So
it's not there, then disregard that box and then move on to the next one.
okay, sige. But basically are we doing the same thing or are we changing our strategy? So our strategy initially was to finish one box first before moving to another. Now we open one box and we see two boxes or more than one box. Okay. Are we having a different strategy now or are we doing the same thing?
Same thing.
Okay, same thing. So
But yeah, sir, your mic is glitching at default.
okay, thanks for that. Okay, is it better now?
Yeah.
Okay, sige. Ayan, so we're not changing in a strategy, but we're still doing the same thing. We finish one box and then we move to the next box once we finish them. Okay. Now there can be two approaches. Okay. So this is the flow chart. You can also treat this as your pseudocode, but in a flow manner. So we first make a pile of boxes to search. Okay. So we look at what boxes are we searching. Okay. While the pile isn't empty, okay, so we can grab a box. Okay. If it's the key, then we're done. If not, then we add the box again back to the pile that we are searching. Okay. So we have this series of uh, pile and search basically that is happening. Okay. If we look to a code, okay, it's similar to this one. Okay. So we have a main function or method, okay, which is look for key. Okay. and then we put the main box as the parameter. We make a pile, okay, that we want to search, okay, from the main box, okay. And while the pile is not empty, we grab a box, okay. We look through all the items in the box. If it's a box, then we add that box again to the main pile. If it's a key, then we end the cycle. Okay, we print found the key. Okay, so here ang ginagawa niya, we are you could imagine like you open a box, you get a box, if and then you open it. If it's a box, then pull it out and then bring it back on the pile. If it's a key, then you end the search basically. Okay, so instead of the approach where you finish the box first um before you move on to other box, so iba naman to. So we basically take out all of the boxes that are inside those boxes and just search through them afterwards. Okay. Now your approach to finish one box first, okay, is the second approach. So if we find the box, okay, we basically again look for the boxes inside. Okay. If wala doon, move on to the next box. Okay. Until ma-consume yung box na yun. Okay. And then if we find a key, then we're done. Okay. How it looks like on code, it's actually like this. So we have again the function here, look for key. And then we just have a generic box. It could be the main box, it could be the nested boxes. Okay. Then for the items in the box, if the item is a box, then we keep looking. Okay. If the item is a key, then we end the search. Okay. So here at this line, okay, this is where recursion is happening because we are again triggering the same function, okay, while being inside the function, while the function is still executing. Okay, so that is recursion, okay, where the method or the function is calling itself. Okay, so as you can see from that example, we have here the look for key method or the function. And then while we execute the look for key, we are again calling it. Okay. We are again calling it. Okay. While it's being executed. Okay. While we're executing it. It's consisting of a base case and a recursive case. So the recursive case is the situation where we will again call for the same function. Okay. So it defines when we will start the recursion. Okay. While the base case will allow us to get out of this recursion state. Okay. Or else we just keep on calling the method will just keep on calling itself basically. Okay. And it will arrive on infinite loops or infinite recursion, you would call it. Okay. Oh, tinapos ko yung plus bigla. Wait. I pressed the wrong button. Okay. So now let's treat it. Let's look at different codes. Okay. So if we want to do a countdown, okay, so we can do it this way, where we print I, okay, and then we call again the function to print the I again. Okay, the next number basically. Okay, so if we have I equals 5 and then we do countdown 5, okay, I'm not sure why it's here. We do countdown 5, then what happens is we count, it prints 5. Then before it finishes the countdown, okay, we actually call the countdown again for the 5 minus 1, which is the 4. So it will call again print 4, and then it will again proceed with countdown. 4 minus 1 is 3, and it will call again, and so on. Okay, so this is the flow, okay, that is happening. So we call countdown with I minus, we print I, and then call countdown with I minus 1, and then we print I again, we call countdown with I minus 1. Okay, now since we want to do a countdown, okay, what happens is if we arrive at 0, okay, it will again proceed to -1, to -2, because the code is allowing it to do it. Diba? So we're not stopping this cycle, basically, where we arrive on infinite loops. Okay? Now, ano yung kulang natin dito? Okay? So again, we have the recursive case. Okay? What are we lacking in this code?
Sir, the base.
Okay? Correct. So the base case. What do you think is the base case for this one? How do we stop the infinite loop?
You have to set it so that it stops at a certain number.
Okay. And what number is that?
5. Oh wait.
Countdown.
0, sir.
0. Okay. So Gerard says that we need to make it stop at 0. So how do we actually do that in a code?
Could you go like when I equals 0, stop? What
Okay,
code
so
called again?
let's use syntax, Python syntax. Okay, so instead of when, what do we actually want to use? If.
If.
Okay, so if I is equal to 0, then we stop the loop. Okay, so the second code here, okay, which is our revision of code number 1, is this one. Okay, so we print I, and if I, okay, medyo generic na siya, if I goes less than or equal to 0, we simply break out of the loop. We do a return, an empty return. Okay, else we proceed with the recursive case. Okay, so this is the flow of that. We print I first. Okay, if I is less than or equal to 1, or 1 yung ginamit sa dito, but this one is 0, okay, then we are done. Okay, if otherwise, we proceed with the countdown call again with I minus 1. So you guys are correct. We are lacking the base case here, which would help us break out of the loop. Okay, so yeah, so tama naman yung example, and you guys were right. So we need to add an if statement here to basically break out of the loop. Okay, now okay, one thing to understand, or an important thing to understand here and the concept of recursion, is another data structure, okay, which is called the stack. Okay, you can imagine a stack of plates, as you can see in the photo. You could, when I want to imagine stack, I always think of Pringles. Okay, where the thing that we can with basically the thing we can get first is the one on top. Okay, so Pringles is an example of a stack. This is supposed to be not first in, first out. Okay, let me edit it for a while. Okay, can you see my screen now?
Yes, sir.
Okay, sige. So again, a stack is a data structure that implements last in, first out. So if you could imagine a Pringles, kung ano yung last na nilagay on top of the Pringles stack, that's the one you will be able to eat first. Okay, so mainly on a stack, there are two operations. We have the push. Okay, so the push is when we actually add something into the stack. Okay, so you can see we push 2, we push 3, we push 4, 5, and 6. Okay, so we add it on top of the stack. Okay, now to remove the items from the stack, again, it's a last in, first out. So if we do a pop, okay, so we remove the 6 first, then we can remove the 5, then we can remove the 4, the 3, the 2, and then the 1 last. Okay, so you cannot actually, in order to remove, let's say, the element 3, you need to remove the 6, 5, and 4 first. Okay, before we can remove the 3. Okay, ganun yung concept niya. Right, so that's a stack. Okay, why stack is important to understand recursion? It's because, okay, okay, mamaya ko na sabihin kung bakit. Okay, let's again look at the different sets of codes. Okay, so we have one function here, which is greet. Okay, what basically it does is it prints hello name, and then it calls greet2, okay, function, and then it prints getting ready to say bye, and then it calls the bye function. Okay, the greet2 and bye functions are here. So greet2 will actually print how are you name, okay, and bye is saying okay bye, right? So how does this work? Okay, on a stack. Okay, first is that your computer would allocate a specific resource or a slot in the memory or a box. Okay, so it's an empty space for now. Okay, and when we start running the greet function, okay, and then we have the greet and the parameter here, which is Maggie. Okay, now it will print out hello Maggie. Okay, as it says from the first line, and then it calls for greet2 name. Okay, so now when we arrive at greet2, it actually stacks on top of the greet function. So while greet is still running, okay, we are calling another function greet2. Okay, so ito yung similar to recursion kanina. While the function is running, we are calling another function again. Okay, or we are calling itself while it is currently running. Okay, now it says how are you name. Okay, then we exit the function. Okay, so once we exit the function, we pop the greet2 box and clears that box, clears out that box basically. Okay, and then once after that, after we end the greet2 function, okay, we again go back to greet, becomes the active function again. Now we are printing getting ready to say bye. So it prints out getting ready to say bye. And then we arrive at the bye function. Okay, the bye function again stacks the bye function on top of the greet. So again, we're not ending the greet function yet. Okay, so we stack a new one to say okay bye until we end the bye, and then we end the greet function. Okay, so we arrive again at the clean state in the box or allotted resource. Okay, so the reason why it's important to understand stack, okay, to understand recursion, is because of the stacking process. Okay, so in this case, the greet function is still there. It hasn't ended yet. It hasn't been cleared out yet from the memory. But we are calling a new function on top of it, okay, which is greet2, or later on in recursion, it's the same greet function with a different parameter. Okay, so yun yung essence niya. Why stack is important. Basically, it's to give you a perception on how a function will actually call another function without stopping the main function. Okay, so yun siya. I pressed the wrong button again. Okay, now let's look at more competitive examples. Okay. If you guys are not familiar with factorials, then we will review them again. Okay, so if we, this is the formula for the factorial. Okay, if we say 6 factorial, we basically multiply 6 or n by n minus 1, which is 5, by n minus 2, which is 4, 3, 2, and 1. Okay, so if we go with 3 factorial, that means 3 times 2 times 1. If we have 100 factorial, that means 100 times 99 times 98 times 97 and so on. Okay, kaya siya ellipsis. Okay, dot, dot, dot. Okay, we could also split the factorial into different components. Okay, so 6 times 5 factorial is exactly the same thing as 6 factorial. Again, because if we look at 5 factorial, it's equal to 5 times 4 times 3 times 2 times 1. Okay, so it's the same case. Therefore, if we have a function fact, okay, just to simplify factorial 6 is equal to 6 times factorial 5. Is that clear?
Yes, sir.
Does this make sense? Okay, makes sense pa. Now, in this case, we have a recursive case, okay? Or if we generalize this fact 6, okay, using n, we have fact n equals n times fact n minus 1, which will be our recursive case, okay? So tama naman. We are calling the same function with just a different parameter within within the original function call, okay? So this is our recursive case now. But again, we have to look at the base case. So what happens after we reach 1? Do we proceed with 1 minus 0? Do we proceed with 1 minus 0 minus 1? We proceed with negative 1 minus uh, negative 1 minus 1. Okay. So with factorial, we don't actually try to reach to 0 because if we do that, that cancels out everything. So that will be multiplied by 0. So we have to end at 1. So that will be our base case for today. Okay, so for this example, a 0 factorial will always be equal to 1. Okay, bakit naging factorial to? Okay, I mean generally 0 factorial is equal to 1. Okay, if you go on your algebra, okay, that's always the case. So we will use this relationship as the base case for our factorial algorithm. Okay, so now we have the two. We have the recursive case and the base case. So now let's craft our algorithm. Okay, just to complete it. Okay, ito na ngayon yung buong formula. Okay, coming from this formula, which is the generic formula, we now arrive at this one, which clearly states out ano yung mga cases natin. So if n is greater than 0, use this formula. If n is equal to 0, n factorial will be equal to 1. Okay? Clear?
Yes, sir.
Okay. So now, I just use a smaller number so I can fit it here on the slide. So 3 factorial will now be equal to 3 times 2 factorial, which is equivalent to fact 3 equals 3 times fact 2. Okay. Now since we called the factorial function again, we now arrive at 2 factorial, okay, which is now equal to 2 times fact 1. Okay, or in this case, it's 3 factorial is equal to 3 times 2 times 1 factorial. Now we called the factorial function again while within the fact 2, while within the fact 3 call. So we proceed and then we arrive at fact 0. Okay. Now once it reaches this state, it will now fall under the second category or second case, which is n equals 0. So now we arrive at 1, okay, times 1, which is still 1. Okay. Now multiplied by 2, multiplied by 3, then we arrive at the same answer, which is 3 factorial equal to 6. Okay. Does this make sense? Is this clear?
Yes, sir.
Okay. So nakita niyo naman, no? So again, this this new formula that we have is an explicit we explicitly express the cases. Okay, so once we reach n equals 0, we use we use the relationship 0 factorial equals 1, okay, as a base case to the recursive case here at the top. Okay, and here at the bottom is what's happening in the actual calculation on the numbers itself and what is happening if we put it on code. All right. So this is the code itself. Okay. So we have fact x. Okay. If x is equal to 0, we return 1. Okay. That's the second statement as from here. This is the second line. If x is equal to 0, return 1. Else, we proceed with x times factorial x minus 1. Okay. Again, the base case is here to ensure that we get out of this loop. Okay. A term is we collapse the loop or the recursion. Okay. And we prevent the infinite loops to happen. Okay. Is this clear?
Yes, sir.
All right. Now let's move on to a second example. Okay. The Fibonacci sequence. Okay. Anyone familiar with Fibonacci sequence? Okay. This is the sequence itself. What is the relationship between each numbers?
You just add the two numbers that came before it.
Okay. Golden ratio. Okay. Yes. It actually extends the golden ratio, but the base, or at least the foundation is yes. So we add the previously two numbers before we arrive on the next one. Okay. So here we have actually it doesn't usually start at 0, but just to make it more explicit, we have 0 and 1, and then we add the 2, so we arrive at 1. Then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5, and then so on and so forth. Right? So if we look at the formula for at least for how we represent them on using variables, we actually have a Fibonacci equals Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay? So the usual questions with regards to Fibonacci sequence is what is the fifth element in the sequence, or what is the eighth element in the sequence? Okay, and this relationship will actually solve or answer that question. Okay, so for example, if we want to understand the Fibonacci 5, okay, then we split it into 3. So this should be 3 and this should be 2. Okay, if we split the 3 and 2, we have the 2 plus 1, okay, or 1 plus 1. And then we split it down again to 1 plus 1 or 1 plus 0, okay, or 1 plus 0 and 1 plus 0. Okay, so you can see that we are branching out the numbers, okay, from one number to the other. Okay, okay, we split it to here and then here to here. Okay, so we break it down. So if we let's say pangilan ba si 5? If we say Fibonacci 6, okay, then it will actually call for Fibonacci 5 and Fibonacci 4. Okay, so if this is a 6, this is the 5 and this is the 4. Okay, and for 5, we have this is Fibonacci 4, which is correct, 2 plus 1 plus 1, and Fibonacci 3. Sorry, mali. Tama. 5 minus 2, 3. Okay. And then 4, we have 3 and 2. Okay. So that the second element in the sequence is 1. Okay. The third element is 1. So we arrive at 2, okay, which is the fourth element. For this case, we have the 5. We split it down to 4. 4 is actually fourth element is 2 and the third element is 1. So tama naman. Okay? We can split it down further. Okay? So for 1, it will be 1 plus 0. And then ano ba isa? 1, I think it's 1 plus it's 0 na yata. Okay, in this case. Okay. So you can see that there's a recursive opportunity here. Okay? Or at least here it's I explicitly stated that there's recursion going on here. Okay, so the question now is what actually happens after 0. Okay, so if we look at the code, okay, this is the code itself. Okay, nauna rin kabila. Okay, let's look at the code on the left first. Okay, so if in case that the number arrives at 0 or less than 0, okay, because of the n minus 1 and 2, so there's a tendency we will arrive at 0 or -1. Okay, then we return 0. Okay, or if the n is equal to 1, we simply say 1. Okay, so we now have two base cases at this point. So pagdating niya ngayon sa 1 plus 0, okay, it will not proceed to -1, or it will not call a Fibonacci sequence when it's 0 or 1. Okay, so we arrive at Fibo and then this is the recursive case, Fibo n minus 1, Fibo n minus 2. To simplify it, okay, the code on the right is a more, as you can see, less case statements. It still uses what you call this? It still uses just one base case, okay, and if it reaches 1, just return n right away, okay, and then it does n minus 1 implicitly. Okay, so kaya hanggang 0 lang siya. So both will actually work. If we want to see what is the fifth element, you just run Fibo 5 or recur Fibo 5. If you want to know the eighth element, just run Fibo 8 or recur Fibo 8. Okay, so you can actually try this out on your computers. Okay. All right. So just to summarize what we've been discussed. Okay. Again, recursion is a function or a method that calls itself. Okay. As you can see on the meme here. Okay. We have a base case and a recursive case. Again, the recursive case starts or triggers the recursion, while the base case stops the recursion. Okay. As you can see, we were able to break down the problems into sub-problems. Okay, so kanina, instead of going through understanding what would be the next number on the Fibonacci sequence, we just break it down into smaller, similar problems. So example again with the boxes. Okay, we our approach with the bigger box. Okay, we can break it down into smaller boxes, and our approach will be the same. Okay, so that actually makes it easier to prove. Okay, if you want to look at the code just to say if it's correct or not, it makes the code elegant. Okay, it helps the programmer to understand what is happening, but it can be less intuitive. Okay, because it's difficult on recursion might be difficult to be understand if we don't have the concept of recursion or programming itself. Okay, so it relies on some mathematical induction knowledge, okay, or math knowledge basically. So it can be less intuitive, okay, if you are not used to using recursion or you don't understand the concept of recursion where it calls itself. Okay, and lastly, to understand recursion, okay, one must first understand recursion. Okay, that is a nerdy joke, but it makes sense. All right. Sige, any questions so far?
None, sir.
None.
Sige. All right. Now, what I want you to do, okay, let's take a break, okay, from 12:42. Okay, let's take a 20-minute break. Let's convene again at 1 o'clock. Okay, and I want you to at least try this out. Okay, just implement this on your Python and see see whatever things that you might find out. Okay, just for you to just basically to prove myself that these recursion works. Okay, so you can try the Fibonacci algorithm or the code here. They are all on Python scripts already. You can try the what's the other one? Factorial. Okay, the factorial code. So I'll present the factorial code. You could take a screenshot and implement it on your own. Okay. I'll give you the time to take a screenshot. Okay na ba?
Yes, sir.
Wait lang,
Okay.
sir. Wait lang. Okay, got it. Thank you.
Okay. Yeah, you can just post it on Discord or send it on your other group chats to help your classmates. Okay, this is for the factorial. And for the Fibonacci, we have two codes, two scripts. You can check them both out again. So take a screenshot of this slide. Let me know if okay na.
I'm okay already.
Okay na?
Good, sir.
All right, sige. So yan, so take send it to Discord, post it on Discord or to other group chats that you have. Just run it, okay? Play some scenarios, okay? You try to recur 100, see if it's correct. 1,000, you can be as basically it tests you lang if the code is running and if it outputs the right answer we're expecting, okay? Just to make sure that it actually falls on that it actually outputs the right answer. Okay, magiging tester kayo for today. So you can explore the three codes that I presented and then I'll see you guys on 12:45 na. So I'll see you guys on 105. Okay, 105. Sige. How was it? Is it running properly or
Yeah, it's running properly naman. Like when I changed it to like 3, it gave the answer, and then if I did 2,
have you tried large numbers?
oh, okay, I'll try. Oh. Oh, seems to be
Okay.
working. Yeah,
I don't know the answer.
yeah, I don't know. That's probably correct.
Sige, let's finish the last one. Maybe you could try a bigger number for factorial. Let's see how it works. Like hundreds or thousands.
Oh my.
Damn. Okay, there's a little bit of lag compared to the smaller numbers, right? You
Yeah,
notice?
because it's a lot more numbers.
Sige. All right. Sige, let's see on your last script.
Oh yeah, okay, wait, let me finish typing it first. Oh, okay.
Is it
Okay. Yeah, it's working. Oh,
and see if it returns the same number as the other Fibonacci algorithm.
it's not showing the result.
I think you should print it. Yeah.
Oh. Okay. It's not showing anything. Did I type something wrong? Or is it taking really long to process it because it's a big number?
I am not sure as well. Okay, sige. Can you try running the other scripts?
Oh, now none
Yeah.
of it's working. Oh no.
Try to restart the kernel. Yeah.
Yeah, none of it's working now.
Oh no, what happened? Again. What just happened? Keyword interrupt. Can you go to kernel and then restart and run all cells? Sige, wait lang, relax lang. Go to the kernel menu at the top,
Where, oh, there.
then restart and run all.
Oh, same thing, nothing showing up.
Okay, it was running. Okay. Sige, it's still running. Okay,
Oh, it's
but
just
we,
taking
we
a
see
while.
that it works, right? So the at least the functions, how even at large numbers it works, it computes something.
Yeah.
You've also noticed, or at least everyone also noticed, that between computing factorial at the smaller numbers and at the bigger number like 1024, there's a bit of lag on the
Oh, there.
1024. Oh, there you go. What
It just
happened?
took a while, I guess.
Okay, sige. So yun. So you've noticed there's a bit of lag. So as you can, as if we go back again to the analysis of algorithms, right? So if we increase the number of operations, if we or the input size, then the overall runtime will also increase. Okay. One thing to notice, or at least to note about the recursion, the emphasis really is on how to break down the problems into smaller sub problems, and then we apply the same algorithm from the bigger problem to the smaller problem. Okay, and we will arrive at the same answer. But when it comes to runtime purposes, it's not always the best option possible. So there might be some cases where running loops will still be more efficient rather than recursion. And there are some instances which we will discuss later on where recursion will come in to divide the entire input dataset into sub problems. Okay. And the concept of dividing the input dataset into multiple smaller input sets that actually makes the algorithm much faster.
Oh,
Okay.
they're the last one printed. Yeah, they're the
Ayun.
same
Oh, it took
answer.
so long. I am thinking it's because of the two base cases. So what's happening is that it checks twice compared to the first one where it only checks once. You get what I mean?
Yeah, yeah. Okay.
Yeah. So like if by the number of operations, diba, parang that's one each of the case. So and then one multiplied by the number of iterations. So let's assume n. So the other one is 2n, while the first one is just n. So it's still that's why the first one is much faster in that sense. But all of them
Okay.
are both of them are linearly growing algorithms. Okay, thank you, Gerard, for sharing your screen and sharing the code. I hope the rest also were able um to try it out. Okay, but I already posted the screenshot of the code on the Canvas page, on our Canvas page, right? Okay. Uh, just to summarize again, okay, again, the recursion allows us to break the problem or the input set into smaller sub problems or smaller input size. Okay, which again will improve our the algorithm efficiency um, of some problems. Okay, as we divide the input data set into smaller sizes. Okay, and then again, it's easier to prove. It makes the code elegant, but it can be less intuitive. Okay, depending on the knowledge of the one reading it, and okay, the corny joke. All right, so that's it for the lecture part. Next week we'll start looking into specific algorithms. So previously we look on some basic search algorithms, but now and sorting algorithms, but now we will look into these algorithms in detail. Okay, so that's it. I will stop sharing or stop the recording.